but we know it's there. E raised to this equals natural log y, equals the absolute value of y. So, but the absolute value of y, I'm going to copy it here, can also be replaced by this, the right-hand side. How do I know? Because a to the nth power times a to the mth power is a to n plus m. So e to x to the fourth plus c can be replaced by e to x to the fourth multiplied by e to c. We're going to change this into a constant. So then the absolute value of y equals the constant e to x to the fourth power. And we know that the absolute value can be positive, I mean the inside can be positive or negative, so we can write this. Any questions? You could omit the plus or minus because you can say now you can recall this or rename this as a constant. That's fine too. So both are acceptable. So y can be written, since this is a constant times e to x to the fourth. This is the solution of this differential equation. Okay, let's look at 30. Let's look at 40. I mean, you can choose. I'm looking at problems 35 through 42 on page 510. If you'd like to choose, feel free to. If not, I will choose. Yes, which one?
How did you get a constant c from e to the c?
This one?
Yeah.
This is e to a constant. So if you give me c, this will always be a number, right?
Oh, okay.
This is the base, which is e 2.7 blah blah blah, and then c is a constant. So you can, if you don't want to, you can still keep it as is. If you don't want to draw plus or minus, you can still put in here e to c. That's fine too. It's not a mistake. You don't have to change it. We like to make it as clean as possible. But if you want to keep it, you can. So I'm looking at 40, which is dy over dx equals x over 2y. Now you understand that I should cross multiply first. Instead, I would just go ahead directly and write 2y dy equals x dx. 2y dy dx, x dx. Now the variables are separated. This is a separable differential equation. And now I can integrate both sides. 2 comes out. I get y squared over 2. I should put a constant here. Instead, I will just want to combine the constants and put just one constant on the other side. I will simplify. I have y squared equals x over 2 squared over 2 plus a constant c. And I have to take the square root. So then I get equals plus or minus the square root of x squared over 2 plus a constant c. Now, of course, some of these, I like to show at least one more and then look at more problems. Some of them are giving us initial conditions. We've had that before when we determined antiderivatives. So the initial conditions are given to us to determine the constant. So let's look at a situation with initial conditions like 44. We have y prime equals 2x minus xy. And we are told that y is 9 when x is 0. And that will help us determine the constant. So we're not going to have a family of functions for every constant a different function, but we're going to have a specific function, unique to the given condition. I still have to separate the variables. How will I do that? So this, I don't like this notation. It's not safe. It's dy by dx in a differential equation. And now I see that these two terms have x in common, or maybe even negative x in common. And then when I factor, I get y minus 2. So I factored out negative x. Negative x times y is negative xy. Negative x times negative 2 is 2x. They're still not separated, but I'm going to do this. I'm going to put y minus 2 in the denominator and dx after you cross multiply if you want to do that. So dy over y minus 2 equals negative x dx. I'm happy now because the two variables are separated completely, on the one side and one on the other. And now I can integrate. The left-hand side, I know, is natural log of the absolute value of y minus 2. And the other side is negative x squared over 2 plus a constant c. Now I'm trying to solve for y. Again, the same thing. E raised to all this, raised to negative x squared over 2 plus a constant c, equals the absolute value of y minus 2. Or y minus 2 equals plus or minus e to negative x squared over 2 plus a constant c, or y equals 2 plus or minus e to negative x squared over 2 plus a constant c. I am told that when x is 0, y is 9. And this is the initial condition. So 9 equals 2 plus or minus, this is 0, e to c. Which we can definitely call c because it's e to c, if that's what you want to do. We could have separated this from the beginning from here and write it as e to negative x squared over 2 times e to c. Same thing. So then, again, the plus or minus comes from the absolute value. We could have done this here. We could have used the, because I'm sure you're going to ask, what about this plus or minus? I don't have to reach this point. So I can put here y equals 9. So 9 minus 2 is 7. The absolute value is 7. So then 7 equals, and when I plug in 0, I get e to c. So e to c is 7. So I come back. It makes it easier then, instead of having the conversation on plus or minus, but it's the same thing. So it's still e to c equals 7. Same thing. Either here or here, it doesn't matter. So then we have y equals 2. If you'd like to put plus or minus, again, we can incorporate the constant, the plus or minus with the constant itself. So this is positive 7 e to negative x squared over 2. And that is final. This is the function. Do we need other examples with or without initial conditions? or we can go ahead and look at word problems.
Another example.
Sure. Would you like to choose? Yes, of course. Would you like to choose? Or you want me to choose?
And choose.
Okay, 46. Is 46 okay? So we have y prime equals 7y to negative 2. We are told x is 1, y is 3. Okay, deceiving. So I will replace it by dy over dx. I will have 7 over y squared, and after I cross multiply, I get that y squared dy equals 7 dx. Y is on one side, x is on the other. I can integrate. So y to the third divided by 3 equals 7x plus a constant c. And y to the third equals 3, 7x plus c. And I take the cube, I apply the cube root to both sides. Okay, I'm told that when x is 1, y is 3. 3 equals the cube root of 21 plus 3c. Again, it could be better maybe if I do it here with x equals 1 and y is 3. Much easier, because now I have to raise both sides to the third power. So this is even better here. I will get the same answer, but it's simpler if I do it here. So 27 divided by 3 is 9, equals 7 times 1 plus c. So c is 2. So all I have to write is that y equals the cube root of 3, 7x plus 2. You can distribute inside if you want. And this is the cube root of 21x plus 6. Given the initial condition, I was able to determine c. So now this is a unique, not a family of functions, unique function. So all this is applicable in all sorts of applications. So let's look at least one problem, like 56 on 511. We're given that dp over dc equals negative 200 over c plus 3 raised to 3 halves. Okay, total profit from marginal profit. Hannes had company's marginal profit, so P, marginal profit, as a function of its total cost, C, total cost. This is the independent, place the role of x, and this is the function. And we are given a differential equation here. Find the profit function, part A. Find the profit function, its profit of C. If we know that when C is 61, P is 10. Okay? So let's find that. Separate. So dP equals negative 200 c plus 3 to negative 3 halves dc. So I separated the variables. dp is alone on one side. After I cross multiplied, I got negative 200. I changed this into c plus 3 raised to negative 3 halves times dc. And now I'm ready to integrate. The integral of dp is 1, so it's p. P prime is 1, equals negative 200 Now C plus 3, I don't really need to change the variable here because number one, it's an indefinite integral, and number two, C plus 3, if I change the variable, let's say into t, C plus 3, dt is still dc. And I don't have limits of integration. So in this particular case, because dt equals dc, otherwise I would have had, if I had a 2 in here, 2c plus 3, then I would have used the change of variable. Okay, so c plus 3 raised to negative 3/2 plus 1 divided by the same number, negative 1/2, plus a constant c. So negative 200 stays outside, c plus 3 raised to negative 3/2 plus 1, I divide by the exact same power plus c. I will right here, not carry it over, right here find c. So p is 10. I will flip this, so I get 400. And when c is 61, I have 64 raised to negative 1/2 plus the constant c, so I can find c. So that was 10, 61 plus 3 is 64. I do have negative 1/2. So this is 10 equals 400 over the square root of 64, which is 8. So this is 50 minus 10. So then c equals negative 40. Okay, so then I have the function p of c. I will have to change this because I don't want you to get confused. It's c and c. This is, I'm going to call this d, not to be confused with the independent variable here. So this c is not the independent variable. It's just a constant that I need to determine because we are given the initial conditions, initial condition. So we normally use c, but here in this problem I cannot use c because there is already a c taken by cost. So this is d. Okay, so then p of c equals 400 c plus 3 to negative 1/2 minus 40. Or you can also write it as 400 over the square root of c plus 3 minus 40. This is the profit function. We solved the differential equation to get that. In part B, we're asked at what cost will the firm break even? Break-even point is when the profit is 0 for the break-even point. So this is not part of calculus, but let's do it. It's just solving an equation. So 400 over the square root of c plus 3 minus 40 equals 0. I will move 40. And I will cross multiply or do this. I can always do this in a proportion. So 400 over 40 is 10 equals the square root of c plus 3. And then I square both sides. So 100 equals c plus 3 or c equals 97. So the cost is 97 for the break-even point. Any questions? I know we are down to about 5 or 6 minutes, but I'd like to at least start the next problem so you have at least 2 applications here. And this is the end of chapter 5. So let's also look at 57. Stock growth. The value of a share of a stock is modeled by dv value over dt time equals k L minus v, where v is the value of the stock in dollars after t months, K is a constant, and L is given to us as 24.81, the limiting value of the stock. We are also told that V of 0 equals 20. This is clearly the initial value, so we can find the constant. Find the solution of the differential equation in terms of T and K. So that's just one question. So very similar to one of the previous examples, I would say, dv over dt. I'm going to factor out -1. So this is v minus, I'm going to replace L by 24.81. And now I'm going to separate the variables. So dv over this one, v minus 24.81, equals -k times dt. And now we can integrate. This is natural log of v minus 24.81 equals -kt plus a constant c. I'm not going to advance. It's easier and better if I do it right this moment. I am told that when t is 0, v is 20. I want to find c right away before I solve. So natural log of 20 minus 24.81 is -4.81. So natural log in absolute value 4.81 equals the constant c. So then we have natural log of v minus 24.81 minus equals minus kt plus c. So e raised to all that equals the absolute value of v minus 24.81 equals e to -kt plus natural log of 4.81. I replaced c by natural log of 4.81. So now v minus 24.81 should be plus or minus. I will separate like I did before, e to -kt times e to natural log of 4.81. So v equals 24.81. This happens to be 4.81. So plus or minus 4.81 e to -kt. Now, the only thing that we have to do, this is it, so that's the solution. The only thing that we need to make sure is that the answer, so I should check whether with this positive or negative, if the value happens to be negative. So the positive or negative here, because it comes from the absolute value. We should check for different times and different k if it's necessary to put plus or minus, but I don't have k. So algebraically everything is correct. Any questions? Any questions?